Good, then let's continue with the second part of this workshop, which is dedicated to BITS, which is short for Brain Imaging Data Structure. And essentially this is a community standard for functional imaging, but also EEG data. And these slides and also the whole idea comes from essentially the Russ Poldrack group, which used to be in Texas, but now is in Stanford, and Chris Gorolewski, he's the one pushing that the most. And these slides are also adapted from slides that I found that he posted on SlideShare. Let's get started. So the idea is, again, we do a brief introduction, and then I provided some functional imaging data and some behavioral data that you can use by looking into the BITS report, getting a little bit into the whole thing. So what is BITS? As I said, it's the abbreviation for Brain Imaging Data Structure, and conforms to a standard for organizing data of human neuroimaging experiments. It has its website, which looks at the top pretty much like what I put there. And there is around that, there's this Institute for Reproducibility in Neuroscience, I think it's called, which is a new, or more newish thing, where essentially the Russ Poldrack group tries to develop and make available tools for reproducibility in neuroimaging. So they have different initiatives. I think one of the latest things that they did was something on pre-processing pipelines, kind of. They also have this idea that I also have to review a paper, that you basically do analysis on other servers of your data, so that that you upload data somewhere and then it's analyzed according to some standardized things. And one can debate whether this is awesome or whether this is maybe not what one wants. But yeah, so these are the people behind that. The BITS standard is communicated in this scientific data paper, but it's a little bit like the Kobidas report. The real BITS meat is essentially in this BITS specification, which is again a more word layout style paper with some details. We in break, it came up whether there's also a Kobidas for EEG or MEG. There is. I think this year I recently saw that they have the first version now online. So by Googling, you will find that. There is also, and this is a little bit further developed now than it was maybe a year ago, there is a BITS EEG and MEG, and I think there are more BITS things even than this, all of which you find on this website. So they started out with fMRI, but of course there are more data types in neuroimaging than only fMRI. What are the core principles behind BITS? So what they tried when developing this essentially proposal for a community standard for data in fMRI, they aimed for a wide adoption and aimed to foster that by simplicity and familiarity. So they actually used the same framework or the same data structure they already established for OpenFMRI. So OpenFMRI has been around for quite some time, I think since 2008, and is a website also run by the Poldrack group, where you can upload fMRI data and also download fMRI data. I think the download is a little bit easier than the upload. There is fMRI data on OpenFMRI. It hasn't had maybe that impact that one could have thought. So the people that post MRI data there are mainly the groups and very closely associated group to OpenFMRI. From the European side, it's of course also this is in the US, and it actually wants a full public domain, or we call it public sharing approach. And I think also data protection here was one of the things that this hasn't really caught on. But BITS is irrespective of OpenFMRI. BITS is just a standard for data, whether you share it or not. But so they use something that is kind of intuitive and also essentially is basically how everyone has stored fMRI data and the associated metadata previously, but a little bit more formalized. Another core principle is that some metadata is better than no metadata. So the whole thing has a lot of non-mandatory things or optional things. So they try to really keep it at a core for what they demand as to be called bits, but then it's quite easy to extend it to other sorts of metadata and other data that one wants to include. They also are independent of external software or complicated file formats, so they basically use file formats that for neuroimaging data that are familiar to neuroimaging people, NIfTY, and for anything else they use essentially very basic TEP or comma-separated value files and JSON files, which were the only ones that I wasn't really that familiar with before I had bits, but they are fairly easy to understand. So their idea is to also to capture most of the experiments, which in fMRI have kind of a standard way of doing things. So you have people in the scanner, you show them a task, you record behavioral data, and you record what you showed them or what you presented to them as a stimulus, and you record fMRI data, maybe you record some other MRI data. But essentially, this is it for fMRI, and this is what they capture very well. So how are these ideas implemented? Some metadata is already encoded in the folder structure and replicated in file names, so that it's fairly obvious what a specific data file corresponds to, because it says in the file name and the folder that this is a specific participant, and it also says in the file name what kind of task or whether a task at all was done. So you have the metadata already in the file that makes up the data. The tabular data is, as I said, just done with tab files. The neuroimaging data is NIfTY in a compressed version, so you just need to compress your NIfTY version, your NIfTY file, and then it's already in the right format. And it uses JSON files for dictionary type metadata and text files for behavior and physiological data. So that's kind of the implementation of these core principles. I mean, talking about an implementation of core principles with these things is maybe a little bit too much abstraction, but this is essentially what's going on. And this is also something that I already mentioned. There are few musts, but many can-dos in terms of making your data bits compatible. So I think these things always sound a little bit greater, complicated, or whatever if one talks about them in an abstract manner to compared to actually talking about them, what is meant. So the very basic thing is that the raw data, which are these NIfTY files, this NEE data, they are organized in folders. And the idea is for the raw data, you have a single folder for a single participant, which is, I think, how most people store their MRI data anyway, although it's not really necessary. But somehow when I started neuroimaging in also a world that is not the European world, although we were in Europe, but it was all in the Nancy Cambridge and MIT world, essentially. We also did it like that, although at that point I was actually quite far from, and this is US, but I was far from how people do it at the Phil, but it was the same at the Phil. Anyway, so it always has been done somehow like this, that you put data from different subjects into different folders, and then you have subfolders for anatomical functional data, maybe for more, and in these subfolders that correspond to different data sets, you then put the actual data in a compressed format. So that's this GZ here. The actually neuroimaging data here in NIfTI format and zipped, so that's GZ. And you also pull in there some metadata, and that's in the JSON files. We've done that for an EEG fMRI dataset that also has quite some behavioral data with it, and it basically, so the bits specification has, in a way, you're quite free to basically in terms of choosing your names. So it requires you to say certain things and number things, for example, but it doesn't say how exactly you should do it. And it's for example, if you have data from a certain task, it doesn't say your task can only have in the abbreviation 3 letters, and one of them needs to be a capital or something. You have quite some freedom. So, but it forces you to basically, it forces you to have this overall structure, which you might have had anyway. And then in terms of the file naming and stuff, it's quite relaxed, and so we, because we had simultaneous EEG fMRI data, organized things in subject folders. We have an additional folder, stimuli and code, and I thought that was a thing, because this derivatives is also of interest. So derivatives is relatively small here. This is where BITS wants you to put your processed data. So what they really encourage is to keep the raw data and the processed data separate, because the raw data is what other people might be interested in using, and if it's all in the same place, you have all your analyzed data, which parts of it you can of course delete. If you're familiar with fMRI pre-processing, you know that you always, for each pre-processing step, generate a new file, but of course you only need essentially the last file that you are then using with the GLM. So BITS wants you, and I think it's also a good idea, to keep your analysis to yourself, and wants to think about raw data. And then we had we had outside EEG and we had inside EEG. And then we have EEG and some behavioral data, and we have anatomical and functional data. So that's a little bit more. So here, this is what we, in our dataset paper, then also document a little bit more. But yeah, it's the same thing as previously. Here with some more explanatory stuff. Just show you there's a big table. Question or finger? The events files, which is the kind of essential metadata, or I would also just call it behavioral data, or whatever kind, or it's also part of the functional imaging data, essentially. They are organized in the following way. So you know that when you record fMRI data, you just continuously create API images, and at the same time people are presented with some stimuli or they do some task, and it's because later on you do a time series analysis of the data. It's when you do the GLM, it's important when things happened. So the events files in bits are organized according to time. So in the first column you have onsets, and they start at 0 at the beginning of a given run, and then they just increase in seconds, and then all the other columns, and you have quite a lot of freedom what you put into the other columns, just encode things with respect to that event. So for example, how long it lasted, which doesn't mean that you need to put this into your GLM as a duration like that, but you have the information. And then in terms of the trial type, and this is the same kind of nomenclature as you have in Kubernetes, trial types are the means, the implementation of your conditions. So if you have, I don't know what kind of factorial or parametric design you have, each combination of experimental factors or each level of the parametric factor will be measured in at least one trial, maybe many, and here you then refer to just the condition itself. So here I just made this up that you have an easy and a hard condition, and then the first thing was easy, and then number 2 hard, and so you get the idea. And here, if you record behavioral data, would be the response types. But essentially, the whole thing here, you have quite some freedom in organizing your data. The important thing is to keep in mind that the events file are basically going from time 0 to the end of the run, and you basically just document time in a timestamp manner what happened. So if you're familiar with Cogent, this was also how Cogent always organized things. I'm not quite sure what Psych-Toolbox, whether they have something like that now. I remember that for Psych-Toolbox we usually wrote our own way of recording the events, but of course then we also essentially used a temporal ordering.
Oh, what I need those buzzwords like onset, duration, and trial type, or is that also free to choose?
Onset, I think, is not free to choose, and I think onset, duration, and trial type, they are actually the things that are always mandatory. Of course, sometimes if you just have one condition, so if you just show checkerboards of one contrast, then it might even be redundant to include the trial type. But this is specified in the bits specification.
Oh.
So everything that is, so there's nothing, so I'm more kind of now giving the overall idea. What is really mandatory and what is not mandatory, that's in the bits specifier, and I also don't know everything that is free, because it's in there. So if you're organizing something, then it's good to look at that. So you don't need to worry about what I'm saying here. So as for these JSON files, which were not that familiar to me when I first saw this, but then on the other hand they were, because if you know what MATLAB structures are, or what structures are in general in programming, then you also know what JSON files are. They are files for key value data, so where you have something that is called something, and that takes on a given value. And basically these JSON files just encode machine-readable these kind of key value data. So for example, in this case, repetition time, echo time, flip angle, slice time, and so on, that you can, for which you then have values. And I think there are also mandatory things for JSON files, like for example TR, because you all know that it's really hard to do a GLM analysis if you don't know the TR. Actually, it doesn't work. Well, it works if you have the onsets in TRs, and I think it doesn't really matter. No, it doesn't. Will it work? But it's definitely a core metadata feature that you need to make sense of fMRI data. I know you will need it because the HF assumes usually a certain length in real time and not in TR time, and then this needs to be computed. So you need the TR or repetition time. It's also awesome with the TR, time to repetition, and repetition time. Anyway, and then they also have demographics files where you basically just list the participant IDs, age and sex if you want. I think this is even, I'm not sure how mandatory that actually is. There are, and this might be interesting for people that go a little bit more into bits, there are quite a number of converters, for example, DICOM to bits that are out there. It's always the question how good they are. So just because something is out there might not necessarily mean that it really works for your data. So when we adapted the bit standard, in our lab. So we wrote some MATLAB scripts that work for transforming my old PowerRec and EEG data from Birmingham into bits. So, and we use essentially SPM tools. So SPM has some tools, for example, for JSON files as well, and that came quite handy. So if not quite sure what the status is of. I'm always a little bit confused because we share the data from our data report. We share that as a private project. So if you want access to the data, then you need to email me. Then you, I think that's actually how we specified in the data report, and then you get added to the OSF project if you sign a data use agreement, which we have to do for this case. And I think some of the scripts are in this project, and some of the scripts we didn't. I think we don't have the bit scripts with the project because our rationale was behind that is that if we share the data, then we share it in the bits format. So there's no need to convert any data into the bits format. And in order not to clutter the project, we didn't include the scripts that we use to convert Birmingham data into bits format. I think that was the rationale, but it's really not a big issue. What is also around is a bits validator. So where you can, there's a website where you can just put a link or upload something, and then it checks whether this is in the bits format. So there are things that might help you to convert to bits, adapt the bit standard. Maybe like always in neuroimaging, it doesn't magically work, and you need some frustration tolerance. But that's just programming, and if everything would be, then there would be no work anymore, and then the computers could do neuroimaging and we could go home. So be prepared that even if there are tools, you will need to adapt them or they won't work under certain things and blah, blah, blah. So you know the drill. Yeah, so that's essentially everything I wanted to say about bits. So you look, if you on OSF, you will find the real bits document, which is actually also quite extensive, and lists essentially for every kind of data that you can think of what you should do. You will also, or when I went over this, is that there are a lot of things that might not apply to your own data set because you don't have DTI data. So there's also then you need to study and memorize how you to share DTI data or whatsoever. So you will get quite quickly of what's going on. Maybe just because we discussed it also yesterday, I think bits is really cool because it first it allows you to within a research group organize the data in a standardized manner, and of course also in the community, even if you're not sharing because of data protection issues or uncertainties, let's say, if you're not sharing your fMRI data that way, it's so much easier if you organize that and then want somebody else to work on that within the community at least there's a common understanding how data is organized, because this hasn't been the case until BITS was proposed, and just created a lot of work when we are analyzing data. So I think it's really it's not an effort for experienced fMRI and MRI people to adopt the BITS standard, because it's essentially, and that's what I'm trying to say, it's essentially how we did it all the time, but a little bit different with different file names essentially. And so it's not a big issue to adopt it. And for everyone else who's really entering, it's a lot of help to have something where you don't need to go through the idiosyncrasies of how this PhD student has organized the experimental documentation or this and so on. So I think it's very good. It's completely fulfilled its purpose. One thing that one also needs to keep in mind, of course, as a neuroimaging person, one always thinks, why hasn't this been around for longer and so on, and why, because there are data standards in the world, why isn't this thing done? I mean, it's very few people who do fMRI after all, and I think it's fair that that there hasn't been really a standard. And I think it's, on the other hand, it's if I'm now talking also to people from other communities which also think about open science, I think we are actually quite far in cognitive neuroimaging specifically with having a data standard, because that you have in science, you have all these sub-communities, and some are really far in terms of adopting certain standards and have them for a long time, and some are actually still struggling with understanding what digital data actually is, and then there's a lot of stuff in the middle. And I think with organizing and doing a little bit more professional standardized work, neuroimaging is actually on a good track. And this whole organizing data also is, keep that in mind from my perspective, it's independent of whether you actually share the data publicly with the world. But even if your data is available upon request, it makes a much more professional impression if you say, okay, we cannot make this data freely available, but if you, because of data protection issues, but if you come to us, maybe, I don't know how you want to handle it, but if you come to us and become a member of the group and then analyze the data, the people who come will find BITS and they will think, cool people here, they know what they're doing. Or they would be like, BITS? No, I don't think BITS is a good format because of this and this, and then why don't I do this like this? But then you're like, oh, whatever. Good. So the exercise that I then have prepared is essentially for people experienced with BITS, maybe not that interesting for people who haven't heard about BITS and for it's the first time. It works quite similar, so I have put up on OSF, I think in 2 folders, Nifty file, which is idiosyncratically named, and also in the same folder put an events file, which is a text file, and this is kind of fairly typical idiosyncratic things, and your task would be then to look in the BITS report and figure out how you would need to rename these files, and maybe create a JSON file for which you might be so you also, I think you need to create a JSON file, just come up with things or ask me. So the TR was 1.5, the other parameters I don't remember right now, or you can find them actually in the paper. But so that's the exercise, so that you look into the BITS report, what is required for fMRI and events, you have the data, and the task essentially comes down to renaming the files. So it's also not really hard, because there are only, how many files? 4 files and so on. You might actually do that by hand rather than now starting to write a program for things. So it's more that you get exposed to it. Yeah. So
Where can you find the report? I can't see it.
I can't see it.
no. Let me have a look. Okay. So